Good morning, class. Mr. Debski here. Hey, we're going to do some fun stuff together this morning by way of video. I'm in the lab and I'm going to do some demonstrations here. I designed or put together some things here which will be for my honors class to show some of the ways that you can visualize changes in reaction rate. And there was 5 different ways we studied in the recent chapter. Now my basic chemistry class, we covered this way back in chapter 12, probably a month and a half ago. So you'd be interested, I'm going to post this on both classes, in watching this video and seeing if you can remember as well. My goal here is to do the experiments and see if you can remember what is going on. Can you tell me what is going on? I'll tell you what the components are and show you, hopefully zoom in enough so that you can see what's going on, and see if you can tell what I'm trying to demonstrate. I'm not going to give any answers, but maybe later this week for my honors class, if we have a review session on Thursday or Friday or a Zoom meeting sometime, feel free to ask, or you can shoot me the answers by email and I can say, yeah, you got it right. Okay, so I'm going to stand up here. You're probably not going to see my pretty face much because I'm trying to zoom in on the demonstrations here, and I may stop and have a second video. I don't know if I can piece these things together, but the first one here I want you to see is 3 test tubes. I've got a piece of paper behind it so you can see so you can see what's going on in the test tube a little better. And each of these test tubes has 10 milliliters of distilled vinegar. Vinegar is acetic acid, remember, and so or acetic acid dissolved in water. And so distilled vinegar is pretty acidic. And so all 3 of these have 10 milliliters of pure vinegar in them. Now what I'm going to drop in each of these test tubes is a piece of metal. And I have 3 different types of metal. The first one right here, and I don't know if you can see that, is a piece of copper. I'm going to drop that in there in a minute. The second one here is this little silver strip. It's a piece of magnesium. And they're about the same size. I tried to make them about the same size so they have about the same surface area. And the third one right here is a piece of zinc. Okay, so copper, magnesium, zinc. I'm going to drop all 3 of them into the test tubes here. And then we'll watch for a minute or 2 or 3. I'm not sure. I haven't done this yet, so we get to learn together. Here goes copper, magnesium, and zinc. Now I'm going to run around to the other side of the camera here and zoom in the camera if I can. Whoops, looks like I'm about, no, there we go. Okay. And let me zoom in a little bit more here. Oh, nice. There we go. Okay, let's see what's going on here. Ooh, look at that one. Can you see that one? That's the middle one. It's fizzing and bubbling, and the magnesium is actually floating at the surface. I think, not because its density is light, but it is probably less dense than the other 2 metals. But probably, look at that, that's so cool. Is that the magnesium? Yeah. This here is the zinc. Let me find, there we go, zinc. And the zinc seems to be sitting there, not doing much anything. And Mr. Copper. Copper, it's hard to get this in focus. Doesn't seem to be doing anything at all either. So I'm going to give that another minute or so. The zinc is so cool. Let me zoom in on the zinc there so you can see. And I'm going to try and put a darker piece, something behind the zinc. This piece of sandpaper that I was using to polish those up. So here you go. Copper on the right, magnesium in the middle, and zinc on the left. And notice there, that is so cool, okay? Lots of fizzing going on with the magnesium. In fact, it looks all cloudy and the magnesium's floating on the surface because the bubbles are just kind of holding it up there. Mr. Zinc, Mr. Copper. Okay, that's all there is to see there. So there is a difference in reaction rate. Okay, the one in the middle, the magnesium, obviously going pretty fast, and the two on the side not doing much at all. Okay. Okay, second demonstration I'm going to do. Let's see if I can change the height of the camera here. Here is my flame. I got a burner, and I'm going to light that up here in a minute and put some things in front of the burner. Let me move that over in front of the blue background over here. Yeah, it's a little bit better. And so we're going to try and see what the reaction rate is on a couple things here, okay? The first thing I want to do the fire with is a piece of steel wire. Let's see if I can find it here. Aha! And I'm using a paper clip. Because paper clips are made of steel. And I don't want to burn my fingers, so I'm using some tongs here. And let's heat up our piece of... There we go. Ooh, look at that. Ooh, it's glowing red hot. Nice. Everybody see that? Pretty cool, huh? I can heat all this steel up. Hold it right at the tip of the flame. You get the hottest part. And that steel is getting super red hot. Woo-wee! Love it. Okay, pretty cool. Okay. Look at that. Woo-wee! Nice. Red hot steel. Okay. Cools off pretty fast. I'm going to lay it down here on the table so I don't burn myself. Now the second thing I'm going to put in the flame is a piece of steel wool. Now I've got two different pieces of steel wool. I've got a piece of steel wool. This is steel wool that comes in a bag like this. People who work with wood use it to sand wood down to a very fine polish or in between polyurethane coats. You can buy this at Home Depot, Walmart, Lowe's, grade 1 steel wool. Okay, so if, whoa! This is just steel, but instead of a, wow. Whoa, check that out. So instead of just a piece of wire steel, this guy is actually torching. Check that out. Really cool. Whoa, 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 whoa. Okay, as long as I don't burn the building down, I think we're in good shape. Now what is going on here is the steel, which is iron, remember, mixed with some carbon, is actually burning. Now, I'm going to do another piece of steel wool here that I have that's not quite as dense as that ball of steel wool. Let's see what happens. Woo! This is so cool. Check that out. And so this guy right here, the steel is literally blowing apart. Woo-wee! And it's literally falling apart. Why is that? The question is, number one, what's going on in the test tubes? Number two, what's going on with the steel wool and why? You should be able to answer the question, why? Okay, woof, stinks a little bit. The third demonstration here is to, let's see, where's my instructions? I failed to write this down, so give me a second here. Let me see. Whoops, nope, not here. Here we go. Okay. So down here. So let's go back down here to the second set of test tubes. These also have vinegar in them. Okay, this one has 10 milliliters of vinegar. The middle one has 5 milliliters of vinegar, or it will in a minute. Okay, so I've got my graduated cylinder here with 10 in it. I'm going to pour half of that into the test tube. Yeah, roughly. And the other one, I'm going to put only 2.5 milliliters of vinegar in. There we go. So 10 milliliters of vinegar, 5 milliliters of vinegar, 2.5 milliliters of vinegar. What I'm going to do is I'm going to top off the second and third ones, the two on the left, with a little bit of water. And so we're going to bring all three of those up to approximately the same level. Not terribly scientific here, but this is for the sake of demonstration purposes. Okay, so the one on the right is pure vinegar, the one in the middle is half vinegar, and the one on the left is 1/4 vinegar. Now, what we're going to put in those is a piece of the magnesium strip that we had before. So let me get another piece of that out and polish it up a little bit with the sandpaper here. Sorry about that. And we're going to drop about a 1-inch strip in each of those test tubes and see what they do. Okay. Okay, there we go. Just cut a piece off of this. You know what? I can hear that original vinegar from over here with the magnesium. I can hear it bubbling. Man, it's sizzling away. It sounds so cool. Okay, if you're watching the test tubes, here goes. Magnesium strip pure vinegar, magnesium strip half vinegar, magnesium strip 1/4 vinegar. Okay, stir that one up, stir that one up, stir this one up. Okay, let's get behind the camera here and see what's going on. Okay, and let me put that slightly dark color behind there again so you can see what's going on. Let's zoom in for you guys to see what I can see. Ooh! So all three of these magnesiums are fizzing away. And I started them within 4 or 5 seconds of each other. So we're going to let that continue to work. It's magic there. You can see all three of them are kind of bubbling away, making some really cool sizzling sounds. Let's see if you can hear this. I'm going to take my microphone. I don't know if you can hear that, but I can hear it sizzling. It's really cool. So there we go. I got 3 sizzlings here. What we're going to do on these 3 is we're going to time it, or we'll come back to it in like 5 minutes and see what's going on, okay? Because all 3 of them seem to be reacting pretty good right now, and I can't necessarily see any difference. If I scan back to our original 3, guess what's happened here? Let's look at that middle test tube. I don't know if you can see it or not. Can you see it? There's nothing in the test tube. That piece of magnesium has completely dissolved in vinegar. Our copper, nope, not doing anything. Our zinc, nope, not doing anything, okay? So, definitely a difference in rate of reaction. We'll see if there's a difference in rate of reaction here. We saw a difference in rate of reaction between the steel wool and the steel wire. And the next thing we're going to do is sugar cubes. Oh, this is a fun one. Let's let's see how this works. Let me find my box of sugar cubes. Okay, here we go. Okay, I'm going to zoom out for a minute here, okay? And if I need to zoom in after I can, let me get the blowtorch. Everybody loves burning things, right? So let's get that going again. Let's get that flame lit up. Okay, I'm not going to use that right away, so I'm just going to let that burn for a second there. My instructions say, take a sugar cube. Here's a sugar cube. Okay, it's about 1/2 inch by 1/2 inch. And it says, try lighting it on fire with a match. Well, okay, here goes. Sugar cube, oh sugar cube, do you light up with a match? That's starting to melt it. That's kind of cool. The sugar's melting. Yep. Kind of liquefied it a little bit, melted a little bit. That's nice. Okay. The second thing it says to do with the sugar cube, use tongs, ignite it in a burner flame. Okay. Here goes. Let's see what happens. Okay. And that kind of is making a stink. And it's making a big puddle of melted sugar on the table. Okay, that's interesting. And then the third thing it says to do is take that cube of sugar and coat it in some ash from some burnt paper. Well, I didn't want to do that, so I found something in the storage room called graphite powder. Graphite, you may know, is pure carbon. I don't know what's going to happen. Let's find out. Here is a sugar cube coated in graphite carbon. Interesting. I'm not sure what it's supposed to do. Let me try another one. It says, try to ignite it in a burner. Rub paper ash on a second cube and try to ignite it with a match. Oh, with a match. Yeah, it didn't seem to do anything with the burner flame. Okay. Uh-oh. Come back here, Mr. Sugar Cube. Uh-oh. I lost the sugar cube in the carbon black. Where are you at? It's so funny. It's looking at my fingers. Oh, yuck. Okay. Oh, it's graphite. It's slippery. Oh, that's so cool. I'm not sure graphite's the best thing to do this with. We'll see. So it says try and light it with a match. And evidently it's supposed to be some difference here. Let's find out. Maybe I need the actual carbon black. We'll try something different in a minute here. Yeah, guess what? Not doing anything. It's not even melting. It's kind of like protecting the surface. I don't know. The other thing I found was activated charcoal or activated carbon. Activated carbon is used in filters, water filters, especially like in your refrigerator and stuff like that. But this is kind of like granules, so I'm going to grind a few up here with my mortar and pestle, and we'll see what that does to the sugar. Maybe graphite is just not going to work, and I need activated carbon instead. I don't know. Let's find out. Nice. This stuff is black. It's going to be a mess. So, sugar cube, and put a little bit of activated carbon on the surface. Just a little bit. Just enough to kind of make it chalky looking. Huh. Okay. And then it says light it with a match. So let's try this one. Come on. Okay, get the match going. Left-handed tongs work here. Urgh. And here we go. Okay, let's see. Huh. I think the carbon is preventing it from melting. I'm not sure what that's supposed to do. Tell you what, let's burn up a piece of paper. Let's take a look at the test tubes for a second here. Let's see what's going on over here. Okay. 3 test tubes. The one on the right hand side is still got some magnesium floating in there and dissolving. The one in the middle still got some magnesium in there and dissolving. And the one on the left still has some magnesium in there and dissolving. All 3 of them still bubbling away. We'll give it some more time. Give me a second to wash this stuff off my hands. Okay. The last thing I wanted to try, and this is kind of off script here, is see if we can get one of those copper wire pieces to do something. And I've got another piece of copper wire here. Let's cut one off of this roll right here. Good sized chunk of copper, and one about the same length. We're going to polish those up a little bit with our friend the sandpaper here. That just gets any oxidation off. And okay, and then the same thing on this one here. And then I'm going to try dropping them in vinegar. Go. And so I'm going to grab another test tube real quick here. Okay, and I'm going to do 2 things over here on the right hand side. Okay. I'm going to take 2 empty test tubes, one in some water that is heated to 60 degrees Celsius, one in some water that is at room temperature, 20 degrees Celsius. I'm going to put our friend copper wire into each of those 2 test tubes and take our friend here, Mr. Vinegar, and add approximately 10 mils of vinegar to each of those test tubes. Ouch. Whoops. Too much vinegar. And vinegar just smells like pickles, you know. So we'll put that one in there. Whoop. Okay, now we'll give that a little bit of time, see what happens there. Huh. And see if anything happens there. Okay, how about this test tubes here? Again, here is our copper. Magnesium's gone. Zinc's still sitting there. On these 3 guys over here, let's see what's going on there. Okay. These are our 3 copper strips. 10 milliliters of vinegar on the right. Ooh, this test tube is warm. Yes, there's definitely some exothermic going on in this test tube right here. There's your piece of magnesium bubbling away there. See it right there? Let's see if I can turn it around. Where are you, Mr. Magnesium? He's in there. He's still in there. He's floating up near the surface. It's hard to see because of all the bubbles. But as long as there's bubbles, he's still in there. Half vinegar, half water. He's not floating. He's not floating, folks. He's sitting at the bottom, but he's bubbling away. He definitely looks bigger than the other one, like the original size, but still bubbling away. And this one, which was 2.5 milliliters of vinegar and 7.5 milliliters of water. Let that focus for a second. There you go. That piece of magnesium sitting right at the bottom there. It's bubbling away, making a lot of gas, but sitting at the bottom, just doing its own thing, bubbling away. Okay, we're going to give those a few more minutes. I'm going to zoom out and up here a little bit so you can see. So we're right at the top. I need to see where my video window is here. There we go, right at the top of those 3. This yellow stuff right here is hydrochloric acid. It's called 37 Bomb A. It's very, very strong. Its molarity is probably about 10 molar. And the reason it's yellow, hydrochloric acid is usually just clear, looks like water. But the reason that this is yellow is I've dissolved a bunch of stuff in this acid before. It's very strong hydrochloric acid. And I really don't want to touch that stopper, but I'm going to just to get it out of there. Now, one thing about hydrochloric acid is as soon as it's exposed to the air, it starts to react with the water in the air. So you'll see it fume a little bit, and it definitely stinks. So don't ever go stick your nose in some concentrated acid. This is difficult to get out, so I'm just working it slowly so it doesn't splash on me when I finally get it off. And we'll drop a few things into the concentrated hydrochloric acid. I need to use my pliers here in a second. There we go. Okay. Woo! We're good. We're good. Woo-woo! Don't smell that stuff. Okay. So what I'm going to drop into this hydrochloric acid, I think you can see it there on the camera, it's right above the test tubes, is I'm going to take another strip of the magnesium and drop it into the hydrochloric acid. Now just watch what happens. Okay, here, yeah, I think you can see it. 4, 5, 1,000, 6, 1,000, 7, 1,000, gone. Okay? Hydrochloric acid is a strong acid. We're going to be covering that in the next chapter. No, 2 more chapters. 7 seconds, that piece of magnesium was gone. This one took about 5 minutes. And we're timing, well, I didn't put a stopwatch on it, but we're seeing what these other 3 are going to do. And they're still fizzing away. And this one over here is now officially gone, okay? So, again, we could kind of start the stopwatch if we were doing an actual experiment here, time how long it takes for that piece of magnesium to disappear. This one's still dissolving. This one still dissolving. So you see the rate of reaction is fast. And then we've got 2 other rates of reaction going on here. Same thing. But what did I change? You should realize that from the chapter, what we're talking about here. Okay? Let's take a look at our copper strips. In the beakers. In the beakers, copper strips are doing, to tell you the truth, nothing. Vinegar and copper, nothing. Vinegar and copper, nothing. So I'm going to crank that up and see if we can get it to do anything. Okay? So I'm going to try one more thing with you guys. And I didn't plan on doing this one, but let's see what happens here. I'm going to zoom over this way. I've seen this done on camera, on the internet before, and in labs. It's probably been decades since I've tried to do it. So, what do I have here? Beaker and sulfuric acid. Sulfuric acid is a strong acid, probably as strong as our friend hydrochloric acid, stronger than hydrochloric acid. And so this is 1 molar sulfuric acid. And we're going to see what happens. Again, science is fun. Let's put a little bit of sulfuric acid into this beaker here. That is not something you want to get on your hands. Everybody can see that beaker, I hope. And I'm going to drop a sugar cube into said beaker. And we'll see what happens. Stand back! I'm the only one in here, so here goes. Not much. Not much going on. I don't think my sulfuric acid is strong enough. Interesting. Okay, let's fish that out and see what happens if I put some magnesium in there. Whoops, my sugar is breaking apart. Okay, we're going to leave the sugar in there. That's very sweet sulfuric acid right now. And let's drop a chunk of magnesium in there, see what happens to him. Where'd you go? Okay, that's definitely doing some. So sulfuric acid and magnesium reacting like the hydrochloric acid. Let me poke that a little bit with our friend. Ooh, there he is. Okay. I think you can see that. I'll zoom in here in a minute. Yeah, there you go. So he's fizzing away. Not as fast as the hydrochloric acid, but pretty fast. He's going to be gone in a matter of a minute or so. Let's zoom back over here. Take a look at our 3 amigos. Okay, you can see again, the one on the right, pure vinegar is gone. The magnesium's gone. One in the middle, Mr. Vinegar is eating away at it slowly. And the one on the left, still got a piece of magnesium in there as well. Okay, so again, fast, medium, slow. What else can we do here? Oh, one more thing to drop into my hydrochloric acid here. I have some metals over here, and I'm going to show you what happens if I put some zinc, powdered zinc in hydrochloric acid. Okay, now I'm just going to take a little tiny little bit of this. Can everybody see that okay? Raise your hand if you can't see this. And here goes a little bit of zinc in there. Let's see what happens to zinc and hydrochloric acid. Ooh, look at that. Whoa! Whoa! Okay. Now, why did the zinc dissolve very quickly in the hydrochloric acid? Woo! Woo! Yeah, don't breathe that stuff. And the zinc didn't do hardly anything in the vinegar, which is also an acid. Here's our zinc chunk over here. Okay? And actually, I'm going to put some of the powdered zinc in this test tube over here and see what happens. Okay, so let me put this back over here and zoom back over here. The one on the left was my zinc. That's a zinc chunk with vinegar. Let's see what happens if I put powdered zinc in there. Nope, nothing. How about if I put the powdered zinc in the hot water? Let's see if we can get that to do anything. So we've got one with the zinc in here and vinegar, one with the copper and vinegar. Nice, bright, shiny copper, by the way. And there is little bubbles inside there. I don't know if they're from the copper or not. This one might take a long, long time. The powdered zinc is not doing anything with the vinegar. So there we have it, guys. Just playing around with rates of reaction. I've seen a couple things here that I could explain to you, but you should be able to explain it to me. There were 5 factors in the chapter on how to change the rate of reaction. I think we demonstrated 3 or 4 of them here, and I tried with the 5th one. Couldn't quite get the temperature thing to work, but we're good. The carbon thing with the sugar didn't actually work. I think that was supposed to be kind of like a demonstration of a catalyst, but I'm not quite sure. Maybe an inhibitor, or maybe it cuts down on the surface area, on the surface of the sugar cube. I'm not sure exactly how that all works on the sugar one. But that's all I got for you today. Hopefully you enjoyed this. It wasn't terribly exciting, but till next time, have a great day.